Hello students, welcome to the next lecture on the IIT JAM. In this lecture, we will describe the PY questions related to the distribution function. Myself, Dr. Harish Garg. You can simply follow my YouTube channel where you can find the PY question playlist and IIT JAM solution playlist. You can see the PY questions related to the random variable I already uploaded, and you can see the previous year IIT JAM mathematical statistics solution is available in this playlist. So as I told you, this lecture I already uploaded the last here. Now in this lecture I will cover about the CDF. So before I can directly move on the CDF, I will quickly go through about the various shortcut tricks which will help you to solve the examination in a reasonable time. Wherever a small f is denoted, that always called as a PDF or PMF, while the capital F is denoted as a CDF, which is defined as of this. Remember, this less than and equality must be present to define the CDF. When you have a continuous random variable, then the probability at a single point is always 0. Then whenever you have a continuous random variable, then you can see I can write this expression as of this nature also, probability at x is equal to x. And whenever you have a continuous random variable, what is the value of this? According to this point, it's a 0. That means whether the equality appears or not, they both will give you the CDF. Remember, this is only for continuous random variable. However, if they are the discrete random variable, then they are not equal, while only for the continuous they are equal. Then how you can find the probability if the CDF is given to you? We all know if the PDF is given to you, how you can find the probability at A, or how you can find the probability in between the A. You can simply integrate from A to B. Fine. But if you have the CDF, then you always use the formula of F CDF at the point A, CDF at the point of A negative. What is the meaning of the A negative? That is the left hand limit of this point A. For example, here, can you find the probability at the single point, say 3? Because what is this 3 is? Because it's a single point. So if I found F3 minus F of 3 negative. So what is that 3? That is the equality. 3 appears here. Answer is 0.75 minus 3 negative means that is a 3 less than 0. That is my here 0.50. So the right answer is 0.25. Similarly, if I found from here probability at the point of say 1. Since 1 is equality appear at here. So it is a 1 minus left hand limit of this. So I can substitute the value at 1 here. So it will be whatever the answer will be here. Now similarly you can find the probability at any of the points, say let's say 4. What is the f of 4 is? F4 minus f of 4 negative. F4 is lies here. So it is 0.75. What is the 4 negative is? Again it lies in this case. So again its value is 0.75. So it comes to be 0. You can see at some point it is a 0. Some point it may not be a 0. So if you find the probability at the point A is 0 for all x, remember it's for all x, then x is said to be the continuous random variable. Like here, you can see this is non-zero. It means this x is not continuous. Fine. And if you find for at least one, then it is called as the discrete random variable. And this concept is very, very important for you to identify whether the variable is discrete or continuous. Second concept is whenever you want to find the probability at this case, then you have to write f of b minus f of a. How you can find when equality? Remember always whenever you take the less than sign, equality must be there, while on the greater than sign it is not there, but it is this. So I can write this number as probability at x equal to a separate and a less than x or less than b separate. Fine. Now you can see that how I can find this value by using this concept, and this is by using here. Also, if you prove that x is your continuous random variable, how you prove that? How you prove x is a continuous random variable? By using this rule. Then this value will be by 0. Similarly, if you want to find the probability at less than x of a, simple less than of b, then I need here as equality. So I can add plus b in this case, and then I can subtract x of b in this case. The second last concept is if you have the PDF, if you have the CDF fx and the expected value, how you can find the CDF expected value from the CDF by using this rule. Otherwise, you all know how you can find the expected value x into small fx. Remember, this is my PDF. So you can use either this formula or this formula. How you can find the PDF from the CDF and how you can find the CDF from the PDF. If, for example, here, how you can find the PDF, you can simply take the derivative of this function. What is the derivative of this function? Is a 0. What is the derivative of this function? Is 3x square over 16. Domain is my minus 2 to plus 2. Fine. How you can find the CDF from the PDF? Firstly, you can write the two cases. Is x is less than 0, less than 2 and greater than 2. Last number is always 1, the first number is always 0. And then the first number is always 0, last number is always 1. How you can use? You can use this formula. Previous value at the common point, common value is my 0. So the previous value, if I say this number is my x square plus 4, then previous value at the common point. So what is the value? Is 4. Anyhow, in this example, it is my 0. So 0 plus lower limit is my 0 to x of 0 to 2. What is the value of the 0 to 2 is 3x square over 8. Can you integrate them? It is my 3 over 24x cube, or you can say it's x cube over 8 is my right answer. Now based on these simple shortcut tricks, you can solve the question in a very simple manner. You can simply scan and join my WhatsApp group for the various shortcut tricks and the discussion. So let's start with this one. Always remember, whatever the statement is given to you, whenever you have the CDF, check firstly whether it's a discrete or continuous. Check at this point. What is the value at x is equal to 1 over 4? So it is f of 1 over 4, f of 1 over 4 minus f 1 over 4 here. Equality appear. So it is 1 over 2 minus negative is 1 over 4, which is a non-zero. So it means this is my discrete problem. So x is my discrete random variable. Now, how you can find this value? X less than or equal to 1. So I can break this into 1 over 4 plus probability of 1 over 4 less than x less than equal to 1. So what is the value of the x? 1 by 4. I computed here. I can take the LCM. It is a 1 over 4. What is that? I can return this is f of 1 minus f of 1 over 4. So that's over. What is the f of 1? Equality 1. Where is the 1 appears? Here. So I can substitute 1 plus 3 is a 4 over 5. What is the 1 by 4? 1 by 4 appears here. It is my 1 over 2. So you can see that 20 will be the LCM. 5 plus 16 minus 10 is a 21 minus 10 is 11 over 20 is the right answer of this problem. Look at this one. Now this is the conditional probability. How you can write the conditional probability is a x less than equal to x less than 1 and x is equal to 0 intersection of this case. So what is the numerator part? The only intersection will be my 0. How you can write this? Since it's a equality and I need equality at here. So it means firstly check whether it's a discrete or continuous. A breaking point is my 0. So what is the value at the 0? F of 0, 0, 0 is a 1 over 4 minus 0. It is non-zero. It means it is my discrete. So how you can write that? I can write x is equal to 0 plus 0 less than x. I need equality, so I can subtract x is equal to 1 also. Now you can substitute the value. What is the x is equal to 0? 1 over 4 minus 0. What is the x of 0 is 1 over 4. This I can written as f1 minus f0. What is the f1? Equality here 1. f0 equality here. It is a 1 over 4 minus p of 1. What is the value of the p is equal to 1 is f1 minus f1 negative. f1 is my 1. f1 negative lies here. So it's a 4 minus 1 3. So 1 over 4 plus 3 over 6 is a 1 over 2. So it's a 3 over 4. Fine. So it's a 1 over 4. So you can see what is the right answer. 3 over 4 is a 1 over 3 is my correct answer of this problem. Now your target is to find the CDF. You can firstly convert into the PDF. Fine. So what is the PDF? You can take the derivative. X over 8 is my 1 over 8. It is my 2x over 16. Fine. Domain is my x from here and from this. Rest 1 is also 0, 0 is 0, else is my 0. Then what is the E of x is? X into fx. X into 1 over 8 from 0 to 2, and it is a x into x over 8 because this is my x over 8 from 2 to 4. So you can solve it. So it's a x square over 2 from 0 to 2. 1 over 8 is outside. X cube over 3 from 4 to 2. So what is the answer of this? 1 over 8 I can complete common. 4 over 2 is my 2 minus 0 plus 64 over 3 minus 8 over 3. So can you solve this? What is the answer of this is 1 over 8 is outside. 2 plus what is that? It's a 50. It's a 58 divided by 3. So 6. 58 plus 6. Fine. So 64 divided by 24. So can you cancel out? 64 over 24. So I can divide by 2. It's a 32. Again I can divide by 2. It's my 6. Again I can divide by, no, it is not there. It's something calculation mistake. Can you again check it? Where is my mistake is? 2 plus, sorry, it's a 56. 2 plus 56. Okay, 64 minus here. So what is that? So it is 1 over 8. It's a 6. It's a 62 divided by 3. So I can divide this. Is a 31. Is a 4. So 31 by 12 is the D is my right answer. Look at this one. CDF is given to you. Firstly, you can check whether it's a discrete or continuous. Breaking point is my 2. I can check at the point 2. F of 2, equality appear here. So 1 over 10, 4 minus 7 over 3 minus f of 2 negative. So clearly say it is a non-zero. 12 minus 5 over 30. So 1 over 6. It is non-zero. That means the problem is my discrete. F is continuous everywhere. Is it a continuous everywhere? No, it's a discrete problem. So it is a cancel out. Fs increases only by jump. Again, okay, you can see if I take any value in between the 2 point, like say 2.1, what is the probability at 2.1? F of 2.1, f of 2.1 negative. So both the values come in here, so it is a 0. So any number which is lies between 2 and 3, the function is my continuous. So if function is continuous, it means the probability of this interval is always 0. So that means it is not increases by jump. Probability of x equal to 2 is 1 by 6. I already computed. That's a fine. What is that? I can see this is my probability of 2 less than x less than 3. And what is the intersection of this is? Only 2.5. Fine. And we can see that 2.5 is in this case. And at 2.5 it is my continuous. Only discontinuity at the breaking point, while all the other points is my continuous. So if this is my continuous, then probability at the single point is always 0. So this is also the right answer. C and D are my correct answer. Okay, now again the CDF is given to you. Check whether it's a PDF is a continuous or discrete. Breaking point is my 0. So what is the f of 0? 4 over 9 minus 0 is 4, which is a non-zero. So that is my discrete problem. The random variable take positive values only at the 2 point. I can found the value at 1 is equal to also. What is the breaking point is 8 over 9 minus 4 over 9. Again 4 over 9, which is non-zero. X is equal to breaking point is my 2. So what is the value of 2 is 1 minus 8 over 9. 1 over 9. So clearly say it only at the 2 point, but it is 3 point. What is that? Probability at, now you can see the sum is my 1. Fine. So what is the meaning of that? It's a discrete problem. It consists of only 3 points. Fine. Then what is the answer of this? 1 to 2, that is my here. So 4 over 9 plus 1 over 9 is 5 over 9. Or you can calculate also by CDF. I can use this value x is equal to 1 because equality, plus 1 less than x less than equal to 2. So what is the probability? 1, 4 over 9 plus I can say it's f2 minus f1. So what is the f of 2 from the table? Or this is a CDF. What is the 2 is here? That is a 1. What is the f of 1? Equality here. It's a 8 over 9. So what is that? It's a 1 over 9. So the answer is 5 over 9. What is the expected value? You can see from here. What is the expected value of the x? It's a 0, 4 over 9, 2 over 9. So it's a 6 over 9. 2 over 3 is the right answer. Otherwise, you can also find the CDF, or you can also find the CDF by using this definition: 1 minus CDF into dx minus infinity to 0 capital F CDF. So you can see from, I can take from, this is from 0 to 1, 1 minus 4 over 9 plus 1 to 2 plus 2 to infinity minus f of x is my 0. This is my 1 minus 1. This is my 1 minus 8 over 9. So this value is also 0. So it is my 5 over 9. Integration of 0 to 1 is 1 minus 0. It is my 1 over 9 from 2 minus 1. So what is that? 5 over 9, 6 over 9. Again you will get as 2 over 3. So either you can use the PDF or the CDF, that's on your choice. Okay, look at this last option. Again there are the two ways: by using the CDF, by using the PDF. If you are using the PDF, so what is the value of the 0 to 1? You can see there is no value between 0 to 1. So the answer is 0. So this option is cancelled. But if you are using the CDF, then you have to, because equality is not there, so I have to write this quantity as here minus probability at x is equal to 1. What is that? This is f1 minus f0. What is that? F probability at x is equal to 1 is 4 over 9. So what is that? F of 1, 1 is here, it's a 8 over 9. F of 0, 0 is my here, it's a 4 over 9 minus 4 over 9. So you can see the answer is 0, but this is 4 over 9. Correct answers are B and C are the right option. Okay, now it is given that it's a continuous random variable. So what does it mean? Probability at a single point is 0 for all A. So you can see the breaking point is my 2. So it means probability at x equal to 2 is my 0. What does it mean? K over 8 minus f of 2 minus f of 2 negative. It must be 0. So K will be my 2. Fine. You may use this case also, like f of 4 minus f of 4 negative. What is that? This is the probability at x is 4, which is 0. What is f of 4? Equality appears at here. So it is a 4 over 8. What is a 4 negative? No, it should be here. It should be here. Okay. So it is my, because CDF is always be the right continuous. So it's my 4 is here. So it's a 2 over 8 minus 4 negative is my here. So it's a 4 over 8, K over 8. Again, you can see K is my 2. Then your target is to write here. So firstly, I can add this equality and minus x is equal to 5. Fine. So I can write this number as f of 5. No, sorry, this is not the CDF. This is the PDF. It's a PDF. I use the CDF. Sorry, this is wrong. This is wrong. This is not a PDF. This is a CDF. This is a CDF. Okay. So if this is a CDF, then I have to write this into 1 to 5 fx. Fine. So what is that? I can break into 1 to 2, 2 to 4 and 4 to 5. So what is the 1 to 2? Is x over 8 2 to 4 is a k over 8. 4 to 5 is a 6 minus x over 8. This is your required target. Now what is the answer of this? This is x square over 2 from 1 to 2. It's a constant number, so I can take it outside. It is 4 minus 2. I can take 1 over 8 is outside. It's a 6x minus x square over 2 from 5 to 4. So what is that? 4 by 2 is my 2 minus half, plus is a 2, so I can say it's a k by 4, plus 1 over 8 is outside, it's a 30 minus 25 over 2 minus 24 plus 16 by 2 is my 8. Clear? Now what is that? It's a 4 minus 1, 3. So there is unknown k. How you can find the unknown k? I can convert this into the CDF. That could be easy for us. Fine. That could be easy for us. Fine. Okay. So 4 minus 1, 3 by 2. So it's a 3 by 2. That's a 16. K by 4. And this plus 1 over 8. This is my 6. 14. 14 minus 25 over 2. So 28, 3 by 2. Fine. Now, so it's a 3 over 16. 3 over 16. That is my 6 over 16 plus k over 4 is the right answer. But I have to find the k also. So that's again a simple, because the CDF is not given. If CDF is given, then I can use this value as same. How you can find the CDF? How you can find the k? The integration of f should be 1. So that is my x square over 2. 1 over 8 is outside from 0 to 2. K over 8 is my constant. So it's 4 minus 2. And 1 over 8 is my outside. It's a 6 minus x whole square over minus 2 from 4 to 6. It should be 1. So what is that? It's a 4 over 2. 2. It's my 2k over 8 minus 1 over 16 is outside. If you substitute 0, 4 will be my 2 of this. It should be 1. So what is that? It's a 1 over 4. 1 over 4 is my LCM. So it is a y 1. It's my k. It's my 1. It should be 1. So what is that? K should be my 2. Fine. So if I substitute k is my 2, it's a 3 over 8 plus 1 over 2. So 8 is the LCM. 4 plus 3. So 7 by 8 is my right answer of this problem. Okay, look at this another one. Now the CDF is given to you. Firstly, we can check if it is a continuous or not. Breaking point is my 0. Fine. So what is the probability at x is equal to 0? F of 0. F of 0 is my 1 over 4 minus 0, which is non-zero. So it means this is my discrete problem. Fine. Then look about this. So what is the value of the x is equal to 0? X is equal to 0, I compute it as a 1 over 4. What is the value at 1.5? Again, I can compute as a 1.5 minus 1.5 negative. But you can see 1.5 is not the breaking point. So it means this is a continuous at this point. So value is 0. What is the 1.5 lies here? The value is my this. What is the f 1.5 negative also lies in this. So this is my 0. Although 1.5 is not the breaking point. X is equal to 2. So 2 is my breaking point. So it is my 1 minus 2 negative. So it is a 1 over 4 plus 8 minus 4 over 8. So 1 minus, it is a 4 over 8, 1 over 2. So 1 over 4 plus 1 over 2. So 4 is the LCM, it's like 2 over 4, 3 over 4, it's my 1 over 4. Last is x is greater than equal to 1. So I can written as x less than 1. Now because this is my discrete, so it is not, I can say this is f of 1 negative. If it is continuous, then it's f1. So what is the f1 negative? 1 negative is lies here. So 1 over 4 plus 4 minus 1 over 8. So what is that? It's a 3 over 8, 5 over 8. 1 minus 5 over 8 is 3 over 8. So what is the answer of this? This is my 1 over 4. This is my 0. This is 1 over 4. This is 3 over 8. So it is my 2 over 4 plus 3 over 8. So 8 is the LCM, 4 plus 3 is a 7 over 8 is my right answer. Always remember, if it is a continuous, then probability at less than equal to x and is less than equal to x, the same thing, but not for the discrete case. Okay, look at this one. Firstly, we can check whether it's a discrete or continuous. At the point 0, it is 1 over 10. You can see at x equal to 0, the value is my 1 over 10, 0 negative is 0, which is, so this problem is my discrete problem. Fine. So you can see the first part, how I can return this portion. Now since we need a equality at this point, either you can add equality and minus, but since it's a discrete, so I can say this is my 2 negative and minus f of 1. Fine. What is the 2 negative? 2 negative is here. 4 plus 7. 4 plus 3 is 7. f1, 1 equality at here. So 4 over 10. It's my 3 over 10. This is the right answer. Second, probability 1 is less than x less than equal to 2. So since I can written as f2 minus f of 1. What is f of 2? Equality here. What is f1 is? 4 over 10. So it's a 6 over 3 over 5. Correct option. Because this is a discrete problem, so I can return this is f of 2 negative minus, because I need a equality, I don't need equality at this point, so I can say it's f1 plus x is equal to 1. I can break this portion. So f of 2 negative here 7 over 10, f of 1 is here 4 over 10. How you can find the f? So this is my f1 minus f1 negative. What is the f1? It's a 4 over 10 minus 1 negative here. It's a 2 over 10. So you can see this value will be cancelled out. Minus 7 minus, it's a 5 over 10. Is a correct option. This is f of 2. Again, I don't need as equality at the lower side, so I can this plus x is equal to 1. So I can, what is f of 2? 1. This value I already computed as here. So this value will be my minus 2 over 10. So it is 8 over 10. So all are my correct answer of this problem. Okay, now it is given that it's a continuous random variable. So what does it mean? Now also it's a CDF. So it means probability at the breaking point should be 0. Probability at the breaking point should be 0. So what is the value of this? 0 is equal to 0, satisfied. At x equal to 2, this is my 1, minus at the point of 2 is a times 4 is 0. So I can got a is my 1 over 4. Fine. Then how you can find the expected value? It's from 0 to infinity, 1 minus f minus infinity to 0 f. Fine. So what is that? I can break this into 0 to 2, 1 minus ax square plus 2 to infinity, 1 minus 1 minus small fx is my 0. So what is the right answer of this? I can integrate this is x minus ax cube over 3 from 0 to 2. This will be my 0. Fine. So what is that? 4, 8a over 3, and so a is my 1 over 4. So this is my 2 over 3. So 12 minus, sorry, it's a 2. It's a 2. So 6 minus 2 is a 4 over 3 is my right answer of this problem. This is the first method. There is one more method that you can calculate it by using the PDF. So how you can calculate it by using PDF? I can write here. So you can calculate by using PDF. So firstly, you can find the PDF. Take the derivative of this 0, 2ax and 0. Fine. And otherwise. Clear? So then what is the expected value of x is? X into fx from 0 to 2. So 2a is outside of x cube. So what is that? 2a over 3 into 8. I can substitute the value of the a is a 1 over 4. So it is 16 over 12. 4 over 3 is again is the right answer of the problem. Okay, look at this one. Again it's a continuous given. Now again it's a PDF is given. Okay, so there are the two methods. I can find this into here, which I can break them half to 1 of x cube and 1 to 2 of 3 over x raised to power 5. So this is x4 over 4 from half to 1 plus 3 over minus 4 is outside, 1 over x raised to power 4. How? You can see the integration of this will be minus 4 over minus 4. So I can substitute it. 1 by 4 is outside, 1 over 4 here, minus 3 over 4, it is 1 over 16 minus 1. So I can take 1 over 4 and plus 3 over 4, fine, and I can take 1 over 16 as a common, it is minus 1 over 4 minus 3 over 4. So this is my 1, this is my minus 1, so the right answer is 15 over 16. This is the first method. Or you can write this term also in terms of f of 2 negative, fine, minus f of, so for that you need to find the CDF. So how you can find the CDF? You can write the cases 0 less than 1 and x greater than 1, fine. Now first value will be 0 always, next value will be previous value plus 0 to x of x cube. So what is that? It's a x raised to power 4 over 4. Is it clear? Now next value will be previous value at the common point, that is a 1 over 4 plus integration from 1 to x of 3 over x raised to power 5. So what is that? Answer is 1 over 4, 3 over 4 is outside, it is my 1 over x raised to power 4. So what is that? It's a 1 over 4, sorry, it's a 1 over 4 minus, so 1 over x raised to power 4 minus 1. So it can written as 1 minus of this. Fine. Now clearly says that is it continuous? Yes, it is. Is it a continuous? It's a 3 over 4. It's a 3 over. Is a continuous? One breaking point is the same value, 0 is the same value. So it's a continuous. So I can return this value as f of 2 minus f of half. What is f of 2? 2 is my here. So 1 minus 3 over 4, 2 raised to power 4 minus half is lies here. So 1 over 4 is outside, 1 over 2 raised to power 4. So I can take 1 over 4 into 2 raised to power 4 common, 3 plus 1. So 4 is cancelled out, 1 over 16, 1 over 1 minus 16 is again 15 by 16. So that's on your choice whether you use the PDF or the CDF. So this is the way you can solve all these CDF related question here. You can simply scan and join my WhatsApp group, and I hope you can like the video as well. We will see the next lecture on the moment generating function. Till now you can like, share and comment on video. Best of luck students. Happy learning.